Hello, everybody, and welcome to tonight's webinar. I am so thrilled that you could be here with us tonight. My name is Sam Anderson. I am one of the regional trainers at C2 Education Center, and I am so happy to be talking about one of my favorite topics, which is APs. I've been working just shy of 10 years, primarily helping students with a lot of school subjects, chemistry, physics, bio, math, calc, stats, and I really love being able to sort of work with them, and when those APs come around, and sort of it's the culmination of everything we've been doing the entire year, and it's just really a great time. So tonight we're going to be talking really about the APs for the STEMs, right? We're going to really take a look at really, six or seven or eight, depending how you all look at it, particular courses and topics and tests. We're going to look at AP Bio, we're going to look at AP Chem, we're going to look at the three different physics exams, Physics 1, Physics 2, Physics C. We're going to look at AP Calc, both A, B, and BC, and then we're also going to take a look at AP Stats. And we're really going to sort of focus on four particular areas, right? We're going to sort of take a general look at the APs as a whole, right? Sort of what to expect on the AP exams, what to expect on each individual AP exam. So we'll go through the format for each of those tests, as well as a bit of an overview of the content, right? Not super in depth, but a good overview so you can get a sense of really what the big ideas to focus on. Then we're going to take a look at some more of the strategy topics, right? Each of these exams have some particular questions, particular ways that you want to approach those types of questions, both the multiple choice and the free response. Then we're going to sort of take a look at some just sort of general methods and ways in which you want to sort of study for any kind of exam. APs especially, and ways of making sure that we're not spending hours upon hours upon hours of just, slogging through practice questions, and, so you can get the most impact for the amount of time you spend on things. So let's just first start with some general stuff, right? What is an AP placement exam? Now, AP courses, for those of you, hopefully all of you are in it, who are taking one or hoping to take one, right? For those of you who maybe are looking to take one next year, are some of the most challenging courses that are offered in high school. They are designed to be a 1 or 2 semester, depending on the course, introductory level or 101 college level class. Now, overall, there are 38 AP courses that run between 7 different subject categories. These subject categories are something like, sciences, math and comp sci, humanities, English, foreign language, and then an interdisciplinarian, and then the arts. Those sort of 7 categories make up the sort of 38 different AP, or made up of the 38 different AP courses. Now, at the end of the year, every one of those courses has an AP exam, and that is administered in the very beginning of May. Now, those exams are tough. So why do we want to take this, right? What is the point of doing this, right? Oh, it's so hard. It's a college level class. I'm in high school. I don't want to do this. Why do we want to do this? Now, at the end of the day, right, the entire goal or drive behind, besides just getting an education and learning, behind high school, behind everything that all of you are doing, is college, right? And numerous studies, over the past several years have shown that the top 3 factors that are used in making college decisions, that admissions officers all say, are grades in your college prep classes. That means grades in courses like an AP, in courses, or, sometimes some schools have like very, courses that connect with a local college, or courses that connect with, that can give you credit for like a local college or community college or some sort of just, general thing, may not be particularly the APs, or there's also the IBs as well. So those is probably one of the most important ones. Now, behind that, and sort of connected to it, is what's called the strength or rigor of the curriculum. How difficult is or are the courses that you are taking in school, right? Are you taking as challenging a course as you possibly can? Schools want to see that. They're aware of how many honors and AP classes your high school has, and they want to know that you are taking the most challenging class you possibly can. And of course, last and certainly not least, and probably the most important one, is just in general your overall high school GPA, right? What is your grade point average? They want the unweighted, because usually what they do, if you give them a weighted one, they will unweight it on their own and then weight it in their own particular way so that they compare people from different schools, because not every school weights their GPA the same way, and colleges want to make sure that they can easily compare it. Now, what that means in general, right, is that you want to get into the most challenging, right? Going to strength of curriculum, right? Schools want to see that you are taking the most challenging classes that you possibly can, and they are aware. Your school's course curriculum is available publicly. You can go to their school's website and it will give like the course catalog, and it will tell you all the classes that are offered in your school, so colleges can find that information very easily. So you want to make sure that you can take as many as you can, but you want to make sure that you can do well in them, right? The sort of classic question of, do you want to get an A in honors or B in AP? Well, the real answer is you want to get an A in an AP, right? You should not try to settle for something a little less than as the best you possibly can. So you want to make sure that you are taking the ones that you can do as well as possible in, because they want to see yourself pushing. They want to see you pushing yourself academically and really having a passion for learning, right? Because at the end of the day, your primary goal, your primary job as a student, is to learn, right? Is to sort of suck up as much knowledge and information as you possibly can. And that is your goal. And they want to see you doing that as effectively as possible. So the real nice benefit of APs is that you can earn a college credit for the APs. A good AP score, now usually that means a 4 or a 5, but sometimes that could be as low as a 3. It would depend on the school. Every school has their own AP credit policy. The easiest way of doing that is just to go to collegeboard.org and type in the school that you want to go to, look it up, and it will give you, for every single course that they accept, the grade that you need for it, and then the number of credits that they give you. But that's really like one of the big benefits, right? It saves you time because you get to take courses that you want to take earlier, because you can pass out of a course. It saves you money, right? If you get out of credits, that's, usually, the way most colleges calculate cost is, dollars per credit. So if you get to pass out 3 credits, you can take, that's 3 less credits you have to pay for. I have a coworker who actually had enough APs that she was able to literally get out of the entire first year of college. That's a lot of money to save, and a lot of time, right? It's a whole year. Means you're in school for a little bit less time. So that's really a good reason that you want to be aiming for as strong an AP score as you possibly can, because they really do have a lot of benefit. Now, the AP exams themselves, right? Why? Okay, so we talked about the great parts of them. Let's take a look at the actual AP exams. Almost all exams, depending on which one, most exams are around 2 to 3 hours long. Usually the exams that are a bit more, your core class exams, your chem, your bio, your math, those are going to be on the 3-hour side. Some more of the elective ones might be closer to 2. But they're pretty long tests, right? They're not a 45-minute test. Now, AP exam scores range between a 1 and a 5, and almost all exams are made up of 2 major parts: a multiple choice and a free response. And so the way that they do it is they take the questions you get right, and then they weight them. They take the question you get right, they multiply by some sort of constant so that they are of either equal or close to equal weighting. So the multiple choice usually count just as much as the free response. The big difference between those two is that multiple choice is yes, no, right? You get it right, you get it wrong. There's nothing in between. But the free response, or FRQs, as I'll probably be referring to them most of the time throughout the rest of this presentation, you can actually get partial credit. The way it works is you start at a 0, and when you get certain ticks, right, you have certain pieces of information in your answer, you get a point. So it is worth doing that, even if you don't know everything. And we're going to talk about this a little bit more when we get to the actual free response and sort of how to go through those particular types of problems, that even if you don't know everything on a free response question, you want to answer as much as you possibly can. You want to put down as much information, as much process, what you remember in as logical and coherent a method as possible, as you possibly can, and answer the question, because you can still get points even if you don't know everything. Now, let's actually look through the AP STEM courses. So let's take a look at each individual test. We're going to take a look at mainly the sciences first, and we'll do the math later. We'll again look at the sort of structure of them first. So AP Bio. AP Bio has 2 major sections, right? There is section 1, which is made up of a total of 69 questions but done in 90 minutes. That is multiple choice for the most part. And then there are 6 gridding questions, right? Sort of for those of you who've taken the PSAT or the SAT, very similar to the questions that you got as the grid-ins for those tests. They give you a relatively simplistic question. Yes, you are allowed a calculator on these questions. And then you are asked to do a basic calculation. It could be on genetics, it could be on, chi-squared test in this case. It's usually bio concept, but you do have to apply math to it. And then you just simply grid in the answer. It's very sort of simple, straightforward structure. You have about, in total, 69 questions in 90 minutes, so they do not separate the amount of time you get for the multiple choice and for the grid. Now, that's section 1. That makes up 50% of the exam. Section 2, on the other hand, is your free response, right? The FRQs, the other 50% of the exam. Is a total of 8 questions, which you get 90 minutes for, which though includes a 10-minute reading period. So they give you 10 minutes to read through the questions, and then you have the rest of the time. They then allow you to open your answer book and then answer the questions for the rest of the time. Now, those 8 free response questions are 2 long ones. What we mean by long ones is they are multiple parts, usually 3, 4, sometimes more parts. There's an A, there's a B, there's a C, there's a D, there's an E. One is usually highly lab-based. They give you an experiment. They ask you to analyze it, because it's science. You should be doing labs in school. So there's, lab-based, and that's one of the things that the APs have a lot of. They have a lot of lab or data-based questions and information. So they have 2 long free responses and then 6 short answer, which are much shorter, usually just requiring a very simple paragraph response versus in, the long FRQs are a little bit more like an essay that's broken up in a bunch of larger paragraphs, right? So like a simple, the long answer free response are going to be like multiple paragraphs. So each part's going to have like a mini paragraph answer versus your short free response might just be 1 paragraph as a whole. But overall, you get 90 minutes for all of it, 8 minutes. We're going to talk again a bit more about sort of what to do with those individual types of questions later on. Now, everything in biology is based around 4 big ideas. I'm just going to sort of pop them all up there for the time being. But these 4 big ideas, evolution drives diversity and unity of life, biological systems utilize free energy and molecular building blocks to grow, reproduce, maintain homeostasis, living systems store, retrieve, transmit, respond, and biological systems interact. These 4 big ideas make up everything that you should know and learn for the AP Bio course and for the AP Bio exam. One of the things I really want to make sure that you all draw attention to is the fact that these concepts are about interactions, about connections. It's not just pure memorization. As the APs have been changing over the last several years, and as the APs change, they become more and more conceptual, more and more about understanding interactions and concepts behind the biology rather than just memorizing a whole bunch of facts. And so you want to make sure that you are always thinking about the concepts. You're always thinking about the connections in, this course when you're planning for the exams. Don't just think about, okay, I need to memorize, mitosis. Okay, how does mitosis work? How do the phases of mitosis interact with each other? How does, the chromosomes, how do they move and function, or how does mitosis and meiosis interact with other processes, right? How does it interact with growth and development or hormones or any other part of the process involved, right? How do those interact? That is the major thing you should be focusing on AP Bio. Now, chemistry, right? Chemistry, on the other hand. Chemistry, very similar, right? There's a multiple choice section. Unlike the bio, there is no grid-ins. It is just 60 flat questions in 90 minutes. Now, for chemistry, the questions will include individual, single item questions that you just answer, as well as sort of questions in question sets, questions that ask you to look. They'll give you a lab, or they'll give you some sort of information that you then have to look at and answer multiple questions on those. Now, part 2, again, 50% of the test, but a little bit over, right? As you can see, the time is a little bit more, right? It's an hour and 45 minutes for 7 questions. Similar to the bio, right? There are some long FRQs and then there are some short FRQs. Very similar, although because chemistry is a little bit more calculation, the need for sort of paragraphs and essays is a little less, especially in the long ones, but they do still expect, and this is really important, in all of these exams, FRQs, short responses, they do expect your answers to be in complete sentences. They do expect your answers to be in coherent, logical sentences that you can put together, right? That you can all sort of throw together, rather than any particular piece of information, right? So it's more about stringing together ideas and concepts and the whole thing, rather than one, okay, I got this question, I'm just going to answer it based on, oh, I just type in this calculation, I just put a number. No, they want in context. They want to know, okay, if you get 2.3 moles, what does that mean? It's not just 2.3 moles, it's 2.3 moles of a compound. Is it 2.3 moles of an ion? Is it 2.3 moles of an atom, right? What is that 2.3 moles? What is it talking about? So make sure that you are writing complete sentences for all of these. Now, just like bio, chemistry also centers around some big ideas, right? It centers around 6 big ideas. Now we're going to sort of break this down to 2 categories. 1, chemical elements for the basic bonds matter. Chemical physical properties can be explained by the structure and arrangement of atoms. Changes in matter involve the rearrangement and or reorganization of atoms and the transfer of electrons, right? Most of these, again, deal with connections, right? They deal with, okay, right, the third one, it's just pure about connections and changes and how things work and rearrange. Again, it's more about concepts, connections than it is about pure memorization. The other 3, right, these are some of the more advanced, right? Rates, collisions, right? Again, rates are based on collisions, right? It's about connections, concepts, changes, communication, interaction, not just pure memorization. So just memorizing first order, second order rates. It's really a bit more about, okay, what causes those? How do you look at those? Thermodynamics, role of energy, and predict and explain directions and changes, right? Again, about connections, about interactions, not just memorizing the 3 laws of thermodynamics. Any bond that can be formed can be broken. Again, how do those connections, those concepts interact? It is not just about memorizing, equilibrium, Le Chatelier's principle, or anything along those lines. Just how does everything connect? Again, very conceptual, very sort of the large part of what we're all trying to get to. Now, AP Physics 1 and 2. Let's talk about the AP Physics. Again, 2 parts, multiple choice, 50 questions. Hour 90. This is for both tests. Both tests have the exact same structure. One of the interesting things about the AP Physics, they bring in these 5 multiple select questions. They bring in 5 multiple select, which means in the multiple select, 4 answer choices. 2 of the answers are correct, and you need to get both to have the question actually be correct. If you only get 1, it is considered incorrect. But you need both in order for the actual question to be considered correct. Now, the free response, slight difference between the 2, right? In Physics 1, there's 5 questions. In Physics 2, there's 4 questions. Overall, it is 90 minutes long. There is 2 questions that are on both exams. One is an experimental design. They actually ask you to create a lab setup, experimental design that you then have to solve. Can be a very challenging problem for people. It's one of the ones I remember my students having a lot of issues, a lot of challenges with, because it is quite challenging. The other one is a qualitative and quantitative translation. What that means is they ask you to explain something qualitatively without numbers, without formulas. They ask you then to calculate something, and then they ask you to connect those 2. How does your explanation without numbers connect to the formulas or numerical calculations that you derived? Again, these 2 questions can be very, very challenging. They're very sort of unique. No other exam really has anything like these. And so they could, especially for a lot of students, those two ones, and they're also, by the way, worth more points. Flat out, they're just worth a bit more points. And so they can be a large challenge. They can be a lot of problems most of the time. When the results come out, that is the one that most people do. One of those two is the one that most people do the poorest on. Now, the other two questions, or three for physics, are short answers, right? Again, one of them actually explicitly requires a paragraph length response. It says it quite clearly, you need to have a paragraph length response to answer this question. Now, what that means is that there is, similar to the previous ones, there are sort of topics that you can go through. There are, again, you have to have those sort of full sentences. You have to sort of look through and make sure that, right, you can think of physics as a cohesive argument and not just a series of formulas, right? We're so used to sort of physics being, okay, I have this formula, I have my numbers, I plug it in, I get an answer. Great, lovely. Not on this, right? They want more sort of thought out, more sort of, again, connectative, conceptual responses. Now, Physics C. We're going to talk about sort of Physics C, and then we'll sort of again go through like those big ideas. Physics C, two different tests, exact same format. So there is two tests. They are usually occur back to back. So there's mechanics test, there's electricity and magnetism, or also known as the E&M test. These are combined 3 hours long. So each test is actually an hour and a half. Both of them contain 35 questions and 45 minutes for the multiple choice. Again, 50% of the exam, individual questions and question sets, and then a free response, which is 3 questions for 45 minutes. One is a lab-based, although it is not necessarily asking you to create a lab. It is still based on a lab being done. And then there are just 2 discrete sort of separate questions that are not, just sort of calculation based as well. Most of them are, again, more formulaic than numerical. But both tests have the exact same format. They're just on different topics, right? So the mechanics test will have this, but would be about like kinematics and dynamics and momentum, versus the electricity and magnetism will have like Gauss's law and, the right-hand rule and more of that particular material in it. Now, physics as a whole sort of runs around 7 big ideas, right? It's sort of like we're going up, right? It was like 4 big ideas for bio, 6 big ideas for chem, now 7 for physics. As you get sort of the more nitty gritty or inside, like the world that we live in, the bigger the broader, the more the big ideas are. 1, right? Object systems have properties, mass, and charge. They have internal structure. Fields, right? This deals both with mechanics and with electricity, right? Gravitational fields, electrical fields, magnetic fields. They exist in space and be used to explain interactions. Again, notice the focus on interactions, not on memorization. Memorizing a whole bunch of formulas in physics will not help you that much. You do need to understand how they interact, how things work together. And again, that word comes up again. The interactions of an object with other objects can be described by forces. Again, force not just on free body diagrams, but on how those objects, forces interact with each other. Our favorite word again, interactions between systems can result in changes to those systems. Those are the first sort of 4. 3, changes that occur as a result of interactions, right? You're seeing a common pattern here, right? Interactions. They're constrained by conservation, both momentum, thermodynamics, conservation of energy, right? Waves can transfer energy and momentum from one location to another without permanent transfer of mass and serve as a mathematical model for the description of other phenomena. Waves, of course, including, light, other topics along those lines. But again, it's still looking at the interaction, okay? Not just memorizing your electromagnetic spectrum, but how does that allow energy to be transferred? Right? Again, more focused on the concept, on the interaction than just on pure memorization. Mathematics of probability can be used to describe the behavior of complex and to interpret the behavior of quantum mechanical models, right? Some of that modern physics. But again, you're looking at the behavior, the interactions, not just memorizing a whole bunch of formulas. Cannot stress enough how important it is to realize that is not what's happening. Now, that's all your sciences. Let's look at the calculuses. So, two calculus exams, right? One's AB, one's BC. There are slight differences between the two. We'll talk about that in a little while. Both of them, though, roughly the same format. Actually, exactly the same format. 45 questions in an hour and 45 minutes. The first part is about 30 questions. Sometimes it's a little bit less, 30 questions in 60 minutes, no calculator. The second part is 15 questions in 45 minutes with a graphing calculator. So you will have to do math without a calculator. For those of you who are a little bit nervous, right? Most of you who are in the AP, right? Your teacher's been usually pretty good about making you do that. But you will have to do math without a calculator. It is a large part. In fact, question-wise, the non-calculator material is bigger than the calculator material. So if anything, you want to be more comfortable without using a calculator than with a calculator. Now, part two, free response, again, 6 questions, hour and 30 minutes. Again, this time the order is flipped, so they do the calculator part first, then the non-calculator. But again, as you can see, right, there are more questions without a calculator than with a calculator. So again, make sure you get very comfortable going into these exams, knowing how to do the calculus, derivatives, integration, so on and so forth, without using a calculator. Now, the topics in calculus. A, B, and BC have a large overlap, which really sort of falls under these particular categories, right? There's a large chunk of limits, one-sided continuity connections to derivatives, and integrals. This is sort of the, for lack of a better word, the A-B part of the exam, right? Is a really large focus on derivatives and integration. Almost equal, right? Sort of equal parts derivative, equal parts integration. Now the BC exam, right, focuses a little bit more on integration than derivatives, although derivatives still show up because of the fundamental theorem of calculus, right? The fact that integrals and derivatives are opposites of each other. Now, BC brings in, or the C part, for lack of a better word, brings in sort of non-linear, non-coordinate system. So it brings in polars, it brings in parametric functions, it brings in sequentials and series, Taylor series, Maclaurin series, these words that might sound really strange and weird, but that's what really is brought into the BC. Overall, right, they're, in a sense, so they're very connected to each other. So, it's really easy to go from AB to BC. So if you're in an AB calculus and you want another AP, BC is a great option. There are some schools I know that sometimes will occasionally skip over the AB and go to the BC and sort of cram it all in. Make sure when that happens, you really are brushing up with your limits and your derivatives early on, maybe over the summer, get some help, get some prep, because you will need it. It will sort of be, particularly challenging and necessary. Now, AP stats. Again, sort of two things. One, 40 questions in 90 minutes. This one, unlike any of the other tests, there are, well, any of the science tests we talked about, there are no question sets. It is all individual, discrete, simple questions about, every question has its data, and that's it. The free response. So the free response does something kind of interesting. Free response, six questions in 90 minutes, 5 short answers, and then 1 investigative task. Now they recommend that in those 90 minutes that one investigative task take anywhere from 25 to 30 minutes at that time. It is huge. Multiple parts, requires you to really sort of analyze data and do a lot of statistics. So it is quite a challenging topic, but right, pretty straightforward otherwise, right? 5 questions or 6 questions, 5 short, 1 investigative. Now, stats. Easiest way of doing it, and College Board is quite explicit, is just to sort of show you the sort of 4 areas of stats, right? So you have exploring data that makes about 30% of the test. Your patterns, departures from data, outliers, etc. Sampling experimentation is about 10 to 15%. Anticipating patterns is about 20 to 30, and statistical inference, your testing, your z-test, your t-test, the test of 2 populations, hypothesis testing, alternative and null hypothesis. That makes up the biggest chunk of the test. 30 to 40% of the test, and will also be a large part of that investigative task that we talked about before. So now that we've gone through sort of all the different test instructions, you've seen all the sort of short answers, multiple choice, so on and so forth. Let's actually talk about how to approach those particular topics. How do we approach those particular areas questions. So how do we deal with multiple choice? So let's talk about multiple choice first. One, and I cannot stress this enough, use the information that's given to you. These questions are meant to be solved. They are not meant to be like challenging questions that you stare at and don't have an answer. They are meant to be solved. They are meant to have an answer. So that means every piece of information they give you is going to be used, is necessary in some degree for the answer. This is not a test that's out to trick you. This is a test that is testing, testing your knowledge, testing your conceptual understanding of these topics. And so make sure that you use all the information that's given to you. Now, there is no guessing penalty on this test. So when you see a question, decide how fast, am I going to be able to solve this? Am I going to be able to solve it quickly? And if you can, either do it, mark that, you're going to come back to it, that you're going to return to it, or just guess on it right away. So if you're unsure if you're going to be able to do it, and say, okay, you know what, I'm going to come back to this. I'm going to come back to it, do it a little bit later. But, if you think you can do it right away. Or, if you're just like, look, I have no shot on this. I don't have any idea. Guess as fast as possible. Move on. Do not waste time on it. Just get through it. Now, because of that, again, there's no guessing penalty. Answer everything. But when you practice for these, timing is an issue. It seems, all the ones I've given you, right, it seems like there's a lot of time for these multiple choice, right? Everything, there is more than a minute per question. Seemed like a lot of times. Some of these are challenging. Some of these questions are really challenging. They're really hard to go through, and you want to make sure that you are practicing under time conditions, because you will be surprised at how fast the time will get away from you. You will think, oh my God, it's 50 questions in 90 minutes for physics, or 45 questions in 90 minutes or actually 105 minutes for calculus. Oh my God, I've got so much time. Some of these questions take 2-3 minutes to do. They take a while. So make sure you're practicing under those time conditions, and make sure therefore that you're pacing yourself. Make checkpoints. Hey, I've got 50 questions due in 90 minutes. I want to be at question 20 by the time the first, 30 minutes are up. I want to be at question 40, by the hour. And I want to just have 30 minutes to do the last 10 questions if you're doing physics, especially with those multi-select, which are the last 5 questions of the test. So make sure you sort of practice, make sure you determine your pacing so you have that process to go through. Now, multiple choice, pretty straightforward, simple, short answers. Right now for the free response, right there are the short answers, then there's the long answer. We're going to talk about the short answer first. Again, for the short answer, you want complete sentences. I cannot stress that enough. They will not accept answers that are not complete sentences. But make sure you have, depending on the type of short response for bio, for chem, aim for like a paragraph, a couple sentences per answer. They give you space to do it. They give you a lot of space to do your free response question. So make sure you use the space that is provided. Do not worry about sort of overwriting. More detail is better than less. The readers have to go through all of it. They can't get bored and cut off halfway through. No, they have to go through it and see if you have the information. And again, remember, there is partial credit. So overload them with information, right? But make sure you're answering what the question's asking. Make sure you're answering what the question is saying. Do not just repeat the question. Do not just put in, random information because it may apply. No, answer what the question's asking, but be as detailed as possible about it, right? Include as specific facts, ideas, concept as you can. Brainstorm, outline. You will have some time, so you can brainstorm, outline this. There will be that space. Okay, I'll put a bullet point with this idea. I'll put a bullet point, with this idea, and then put together your response, so that you have a little time to think about it. You have a little time to compose your actual response. Now, make sure when you're going through this that you are making it as easy on your grader as possible. Again, the way your grader does it, they read through your answers, they look for specific words, phrases, sentences that they are in the scoring guidelines, and you can find all that, how the scoring guidelines look on College Board. Scoring guidelines have sort of certain pieces of key information that give you points. And so the graders are looking through your responses for that pieces of information. And so you want to make sure that your answers are formatted in such a way that those graders can find the information as easy as possible. You don't want to spend them have them spend forever looking through it or going, is this sentence really that piece of information? No, you want to make it easy. You want to make it straightforward and easy to pick up. Now, in both short responses and in long responses, especially in the sciences, they have a lot of key terms. I'm just going to sort of pop them all up here for now. The big ones you want to make sure you're looking at are justify, determine, derive, and outline, right? Those are the big ones, and explain too, right? The ones that require a little bit more sort of in-depth thinking, these are the ones that you're going to see the most often because, again, this test is becoming more conceptual, right? It's about the interactions, right? I said that word a lot when I was talking about physics, I know, but it's about the interactions. It's about how things connect. And so you want to make sure that you are doing what each of these questions is asking. So they all have very specific pieces of information that they're looking for. I'm not going to go through each one individually. Take a look, take a picture of this. This will be recorded. So if you'd like to view this webinar later, it will be recorded. You can just use your registration link to click on it and go through it all again. And so make sure that you are doing what these questions are asking. Now, for the long response, very similar to the short response. Make sure you go through the whole problems, right? Long response is one of the big differences between them and short responses, that they usually have more than one part. These parts are often connected to each other. So sometimes part B is needed to answer, needs information from part A. So make sure you are doing those parts in order, if possible. Sometimes you'll get questions that don't require it and you can do those out of order, but it's usually best to do them in part and making sure that you are addressing every part. Again, you don't lose points, you only gain points. You start at a 0, you work your way up to 100. You don't start at 100 and work your way down. You start at 0 and you gain points based on your responses. So make sure you're answering and addressing everything. And make sure, again, you're putting in as much. Do not just repeat the question, because repeating the question does not get you any points. You need information. You need to pull in outside sources, information, extrapolate connections, etc. Again, keep in mind that the way the scoring guidelines work is that they are looking for specific words, phrases, or sentences. That means your language and your vocabulary is critical. Use the terms as specifically and precisely as you can. If you're going to look at sort of where's the only memorization stuff that you're going to need to do, this is it. Make sure you know your terms. Make sure you're using the proper terms. Don't just say, say Le Chatelier's principle, not the laws of equilibrium, right? One's specific, the other one's a little general and in a sense isn't really there. You want to make sure that you are specific, because that is, they're going to give you a point for Le Chatelier's principle. They're not going to give you a point for laws of equilibrium. Same thing with like laws in physics. Be specific. Don't just say laws of thermodynamics. Is it the first law, the second law, the third law? Same thing for Newton's laws, first, second, or third. Be specific, because that's what gets you the points. And so usually point-wise, right? Because there are less questions and in some ways, right, there are less sort of questions, parts, etc. on these long responses. Each long response, the individual part, is worth a lot. Each point usually has a larger multiple to get to that weighted part. So make sure you are checking your work. Make sure that you are double, triple checking. You should have the time. Again, they give you a lot of time to do these questions. Calculus, for instance, it's like 15 minutes per question. So make sure you spend that time. Double check, triple check your work. For chem, for physics, make sure you check your significant figures. Yes, that does matter on this exam. And label everything. Do not, like, there are in calculus, there are points given for having your units. So make sure you have your units for everything. Do not leave out units. Do not leave out anything. If you think it's necessary, put it in there. Now, let's look at sort of study plans, right? Okay, so as we've got X number of weeks until the AP exams, depending on what AP exam it is that you're taking. So how do we go about doing this? How do we sort of, in a sense, study so that, we're studying smarter, that we're studying as effectively as possible? Now, the first thing I can tell you is to start early, right? The best thing to be doing, right? These are year-long classes. Keep up with it. Do your work. Study materials. Study for your quizzes. Review, right? Hey, take a look at the stuff from 2 months ago, from your first semester, from 3 months ago. Look at that material often. Don't just wait until 2 weeks before the AP exam to look at the stuff from September, from October, from November, right? Look at it now. And so make sure, that is critical to make sure that you're sort of going through this. Start early, start preparing as early as possible, start looking through your material, reviewing your material early on. Don't wait till the end of April when the test is in May. Now, usually, we always sort of say that the latest you should at all start preparing for these is in March. That is the latest. Earlier is better. February is great. January is awesome. December is phenomenal, right? Getting a start like around Christmas break, awesome idea. But regardless of when you start, the first and foremost thing you need to do is you need to make sure you're building a plan, that you are crafting a method, a way of tackling all the work, all the concepts, all the interactions you need to do to get through this material. So first of all, set your weekly goals, right? What do I want to get done today? What do I want to get done by the end of this week? It's critical. I cannot stress it enough. Making sure you set and also keep those daily goals, right? Now, when you're setting those goals, you want to be specific. You don't want to just say, okay, I want to learn derivatives by the end of the week. That's very nebulous. It's very sort of broad. Specific. Do you want to learn, review your product, your quotient, your chain rule? Is that what you want to do, right? What specific topics in derivatives do you want to look at? What specific topics in mechanics or in dynamics that you want to look at, right? Be specific. And what is the mechanism by which you're going to go about doing it? Are you going to review your notes, write questions, write quizzes, do flashcards, do some practice questions? How are you actually going to tackle the particular challenges that you are looking at? Then, right, you want to sort of, when you're going through this, right, there are some times that you're going to sort of do very highly targeted review, right? There's a particular area or topic that you are weak on that you want to make sure you're spending time with. But, right, these are a test. This is sort of, in a sense, a general review test. It tests everything that's covered over the entire year. So you want to make sure you're building in practice tests. You're building in, hey, I'm going to do this whole free response section. This more sort of comprehensive, broad review as well. Now, best ways to sort of go about doing this is, use the existing tools that you have. Your class syllabus, table of contents from your textbook, a prep book. You want to get like a McGraw-Hill, a Barron's, AP prep book. Great idea. Again, they'll have a table of contents. They'll have sort of a breakdown of the topics that you need to work on. You can go through it. You can see, hey, I really remember this topic. I don't remember this as much. In terms of like a table of contents of textbook, I'd recommend either copying or printing a picture, from the table of contents and just going through with like a pen and saying, okay, maybe rate everything on a scale of 1 to 5, right? Where 5 is, I got this mastered. I remember every single thing from it. I'm going to do great on it. And 1 is like, I don't remember anything that my teacher taught about in class on this topic, right? So maybe go through, you rate those, you sort of say, okay, these are the areas I want to focus on. But again, make sure you're building in that comprehensive review. Because again, you want to make sure you're building in practice tests. But, and I cannot stress this enough, doing only practice tests will not help you. In order for doing tons and tons of practice tests to help you, you need to do like 50 to 100 practice tests, right? If you think about it, right, doing a practice test is sort of just like, I'm going to do a bunch of questions. I'm going to see what I get wrong. I'm going to correct those particular questions. I'm going to do a whole other set of questions that have nothing to do with the first set of questions I did. And I'm going to do the same process, right? In a sense, you're doing the same thing over and over again and expecting different results. Einstein defined that pretty clearly. And so you want to make sure that you build in your practice test, but you build in your practice test as a way of marking your progress, marking where do I stand, what have I accomplished, where do I need to go, maybe say, oh, this topic that I thought was a 5 that I thought I really knew, maybe I don't know it as well as I thought. That's what you want your practice test for, not just to do. Now, regardless of what happens, plans change. Things come up, right? emergencies, last minute school projects that you need to deal with. Things come up, things change. Make sure you have some room to flex your plans, because I guarantee you everything you planned is at some point in time going to go out the window. So here's sort of a quick sample plan, right? So let's say on week 4, right? We're looking at like 4 weeks out. So let's say if we started now, right? So 4 weeks from now. These are the, this is actually for language, but let's say we were doing it for, chemistry, right? So maybe in chemistry, I'm going to be reviewing equilibrium. I'm going to review Le Chatelier's principle. I'm going to take a look at doing ice charts. And then I'm going to do some multiple choice questions. I'm going to do some multiple choice questions on equilibrium. I'm going to do some general multiple choice questions. I'm going to do a long response question and then a couple short ones. Now, one of the important things to understand is as you get closer to the test, and so, that example is again sort of like what your weekly goals were. But again, as you get closer to the test, you want to sort of start working your way more towards, again, that, sort of building of those timing, full practice test time, free response, again, maybe like an individual, chemistry, again, if it's 7 questions on the exam, I'd spend 15 minutes for each question. Okay, so I'm going to do, one free response, I'm going to do it in 15 minutes. Or because, again, there are some long ones and some short ones, I'm going to do one of the long ones in 20 minutes. I'm going to do one of the short ones in 10 minutes. You sort of time out either entire practice tests or parts of practice tests, right? But again, make sure you build that flex in. Okay, so I'm going to do a practice test, and I'm going to run through the practice test, and I'm going to spend the rest of the week working on like the 3 topics that I struggle most with. So based on how I do on those practice exams, I'm going to just work on those topics, and then I'm going to take another practice exam at the end of the week, right? Again, so you make sure when you have your plan that there is some targeted review, sort of, again, like we were talking before, with like Chatelier's principle and equilibrium, build some practice, right? Multiple choice free response, and then again, some practice tests, especially as you get closer, and build in that flex. So you want to make sure that your plan has all of that moving forward. Now, kind of saw this one coming, right? Because I've been talking about the entire time. Regardless, when you study, be concept oriented. All right. What was the word I used all the time when I was talking about physics? Interactions, right? I used that all the time. It was in like 5 out of those 7 big ideas, right? It's all about the interactions, all about the concepts and the connections, and not just about memorizing a bunch of facts and figures. And so make sure that when you study the exact same way. You focus on how things connect, how things interact. First of all, it means you won't have to memorize as much, right? There's not as many formulas. There's not going to be as many, random, specific pieces of information that need to be crammed into your brain. It's more, okay, this connects to this, which allows me to do that. And again, that's what the test is going to test you on. It's going to test you on the whys, right? My favorite question to all my AP students was why. I would just ask them why. Oh, well, this is the case. Okay, why is that? Well, it's because, when they interact, they do this. Why do they do that? Again, play the why. Always look for the why behind why something is occurring, why the thing that's making that occur is occurring, why we use the formula the way it is, or why the particular variables are in that formula. Why is calculus useful? Why do we have a t-test and a z-test in stats, right? Play the why game. Be able to answer those why questions, so that you can go as specific to as general as possible, especially when it comes to the why, right? You want to sort of answer highly specific questions about like very specific laws in chemistry or physics, to more sort of general things about like why collisions matter. And again, look at sort of how you can apply those concepts, right? What about those concepts can be applied and you can sort of connect to what it is that you're working on? And because that is going to be, right, that's how the test is going to work. It's going to ask you to apply concepts on these questions. And so you want to make sure that that is what you're doing when you're studying, that is what you're doing when you're planning, and that is what you're doing when you're preparing. Now, again, we sort of talked about practice tests. When you do practice tests, you want to make sure you are practicing as realistically as possible. You want to use the format questions, the exact formatting of the questions if possible. The order of the questions, right? Again, like calculus, right? Multiple choice, it's non-calculator first, then calculator. Free response is the other way around. Practice the same way. Hey, I'm going to do my non-calculator stuff first, and then I'm going to do some calculator at the end of the day, right? Make sure, right? Again, twice as much non-calculator as calculator. You want to make sure that you're not doing twice as much calculator as non-calculator in calculus, right? You want to make sure that you're practicing the exact same format, the exact same order, and with the exact same timing, right? 15 minutes per free response. You don't want to be spending 30 minutes on a single free response question. That's not realistic practicing. So, ways of doing it, right? Test-like conditions. What I mean by test-like conditions is I mean locations that would be similar to the test. Not in your room, right? Not in front of where there's a computer and your phone, put your phone away. Put your, turn your computer off. Sit down in such a way that you have limited distraction, right? Maybe on a dining room table or, a kitchen table, or just, put on headphones, not music, headphones just to cancel all the noise around you, right? So that you're in those test-like conditions. You're working in the particular, testing and timing mechanisms that you would actually, have, right? Because in the actual test, you're going to be in a classroom. You're going to be in a room with a bunch of people that are going to all be taking the same test, so it's going to be quiet. So make sure it's the same way. It's quiet, there's no distractions, your phone's not going right, you can't use your phone on the test. Put your phone away, give it to your parents. Time yourself, or get somebody else to time you. Get your parent, a sibling, a best friend, time you for a free response question, right? And, grade it. Again, let's say you're doing free response. All the scoring guidelines and the mechanisms for which to grade those scoring guidelines, those are on College Board. You do not need to, hunt down, oh, how do I score this free response? College Board gives you the information. So go print out the scoring guidelines, either grade it yourself, maybe get your parents or your friends to grade it. Hey, maybe even go into your school teacher and said, hey, I took a couple free response. Would you mind going through these for me, right? But grade it, so you can see, are you missing certain points, right? Oh, was there a question that you didn't know that maybe you got a couple of those partial credits on, right? So make sure you get your work graded, and most importantly, try your best. Take this seriously. Pretend that it is the actual exam and take it as seriously as possible. And the best way of doing that is to make sure you are studying actively. Now, there are two forms of studying, right? There's active and then there's passive studying. Most of my students, I'll be 100% honest, a lot of them, right, they did passive, right? Oh, I'm just going to read through my notes, or I'm going to, look at my old quizzes. I'm going to read the chapter in the textbook, right? Or I'm going to stare at a bunch of terms and try to memorize it. That is not passive. That is going to have a very low rate of retention in your memory. That's just a biological fact, right? Viewing, reading, that connects to your occipital lobe. That's in the back of your brain. That's in the opposite side of your brain as your memory. Your memory is in the very front of your brain. And it's connected, your memory is connected to doing, to your motor skills, to your other senses, far more than it is connected to your sense of sight. And so utilize those other senses as much as possible. Retake your notes, make new sets of notes, make flashcards, take quizzes, do questions, right? Do things. Don't just read things. Teach somebody. I always say one of the best ways of making sure that you know something is that you are able to teach it to somebody else. Can't stress that enough. It is 100% true. I know, even, and I've always been a math and science guy, but even my ability to really sort of not know my math and science got so much better the more and more I taught it to other people. So teach it, grab a sibling, grab your mother or your father or a friend and say, hey, let me explain this to you. And after I explain it, if that makes sense to you, then I got it. Great, do that. I guarantee it will help. And, if you're still struggling, if you still want to sort of go through, ask questions, talk to, feel free to come to us, right? So C2, we offer a comprehensive, personalized program. Especially when it comes to APs, we cover all manner of APs, everyone that we've talked about today. Center, come in, talk to our center directors. They all know a lot about the APs. Teachers all have to sort of score in the top 5% of SAT, ACT, AP. I know when I was not expecting, I had to go down. I had to take like a practice AP multiple choice for every test that I wanted to teach to make sure I could actually score like a 5 or above or as close to perfect as possible. And so, like, our teachers are experts. They're great. Our center directors know a lot. If you have any or all questions about anything to do with this, any questions about any APs, if you need some help sort of maybe putting together a plan for how to study for those APs, you want some extra practice, some extra, help, please, once I close out this webinar, there will be a survey that will pop up. It will ask you for your name, a phone number or email that we can contact you with, and then your zip code. The zip code is really important so that we can match you with the closest center. If you have any other questions, if you would like to be contacted by a C2 to either get some additional questions answered, sort of talk to somebody about the APs or about anything else to do with the college application process, please do make sure to fill out that survey. Again, make sure you leave your name, phone number, so that we can contact you, and a zip code so that we know exactly where you are nearest to. Thank you so much for listening. I hope everyone has a wonderful night, and for all of those of you taking the APs in May, good luck. I wish you the best, and thank you again so much for listening. Have a wonderful night.